Hello, everybody. My name is Ryan Marcotte Cobb.
And my name is Trenton Ivey. I'm one of the security researchers with SecureWorks Counter Threat Unit. I'm a counterpart to Ryan. I play the offensive side of our research team, and Ryan helps with the defensive side. Our team's mission is to outpace malicious adversaries by creating a safe and structured space for collaborative conflict. And so today we're going to take some time to look at what we mean by malicious adversaries and consider how they evolve over time. And we're going to discuss what we mean by collaborative conflict and how our team leverages that to try and help outpace the adversary. And then finally, Ryan's going to share some real-world examples of ways that we've implemented this in our infrastructure and some of our surrounding technologies. So first, I think this is probably pretty self-explanatory, but by definition, adversaries have opposition. And in security, we often think of the adversary as the one that's trying to hack into the environment. But from the red side, I often consider the blue team to be my adversary. And so really who the adversary is depends on perspective. Another key point is that opposition can create competition. If you could imagine the first human that picked up a rock and realized that they could use it as a weapon, that must have been a drastic power shift at the time. But it wasn't very long before somebody else probably figured out how to sharpen stone to gain that competitive advantage. Of course, not long after that, we could attach it to a stick to make spears. And then, of course, we could shoot it from a bow to make arrows. As technology advanced, we figured out that we could use things like gunpowder to shoot projectiles much farther and faster. Of course, that was not enough. So we had to figure out ways to minimize it and put it in our pocket. We could follow that up by shooting it faster, by automating the whole process, making machine guns. Later, we figured out how to just drop the explosives on people. And of course, we figured out how to make the explosives bigger. Now we're discussing futuristic weapons where we're launching giant titanium rods from space. So you can see that there's this huge advance through technology and capability. And it comes down to this idea that competition increases capability. If you look at this over time, what you'll see is you may have two adversaries that are opposed to each other, but as they're both vying for that advantage, if they want to maintain power over time, they have to continue to increase capability. So if we look at this from a cyber perspective, you can see that, for example, network service exploitation was a very common way to get in earlier in the game. So the counter to this was firewalls. Let's block those network services from being exposed externally. The follow-up to that is, well, if we get in, we need to make sure that we can stay in. So this idea of persistent implants and malware came about. To counter that, blue could use antivirus. Then, of course, to counter that, red came up with the idea of living off land so that they could avoid having to use implants as much as possible. Then came the idea of the EDR EPP solutions, where you have to then detect these living on land capabilities. So then the follow-up is let's figure out ways to bypass this. And kind of the current culmination is this idea of XDR. So let's look at not just endpoint, but everything from cloud to all around to come up with this defensive capability. And this back and forth will continue. I don't suspect that it will stop anytime. There will always be continued advancements. The other thing is that this graph is just as an example, it's probably not the most accurate in the world, but it does have, the key point is that there is this continuous increase in capability. Is one side of the adversarial perspective increases capability. The other side has to counter. And over time, that results in this increase. I absolutely love this quote by John Boyd. He was a fighter pilot that fought in the Korean War. He later became an instructor and was known to be one of the best dogfighters. He could get himself out of a disadvantaged situation all the time in a very short period of time. But later in his career, he tried to figure out how to quantify what makes a fighter pilot win. And I love that, that idea of quantifying something as difficult as what makes a fighter pilot good. Because I think in cyber, we have the same kind of question of how do we quantify what makes an offensive or a defensive team able to win. And so he came up with this idea of this EM theory, where he looked at some various variables of a jet, and so things like speed and drag, and that led to a really good idea. But what he found was that it wasn't just the jet that mattered; it was also the pilot's perspective. And so he codified it in this thing that's really well known. It's probably almost overused, but this idea of the OODA loop, which is this observe, orient, decide, and act. And in that, you go through this process where first you have to understand what's around you, and that takes time. And then you have to orient to what that means. You then have to decide on it. And then once you've made the decision, you have to then act on it. And each of these steps takes time. And the one that can run through this loop the fastest wins. And so there's a couple of ideas. One of the most common ideas is just to move it faster. The other concept is potentially figuring out ways to slow down your adversary's loop by disrupting it. But at the end of the day, the key point is that those that can run through the loop fastest will win. And so we understand how the adversary evolves. We understand that this competition leads to an increase in capability, and that the adversary that can run the loop fastest wins. And so we wanted to think about ways that we could actually take advantage of this idea to increase our research team's output. If you look at two opposed adversaries that are against each other and not connected, they're going to be running their loops at different speeds. Not always, but oftentimes red is smaller and less resourced, but they can run much faster because they have the ability to adapt much quicker. Whereas blue, there's often a lot of resources being thrown at defense, but it's often a harder problem to solve because there's so much to see. But the key point here is that these are out of step. What we found is that if you are creative on intentionally creating touch points between these two OODA loops, you can actually make them both go faster, and you can get them in step. And this is not a new concept. This is really the underlying premise to a purple team exercise. What we find is that as you intentionally create these touch points and you have the teams increase capability, you get the same power distribution curve. But then when you compare that to an adversary that isn't fortunate enough to have collaborative conflict as part of the process, so if you have an entirely adversarial team or an entirely defensive team, they aren't able to adapt as fast as those that use this idea of collaborative conflict. I mean, it's one of those iron sharpens iron capabilities, but you actually have to go through the process of using iron to shape iron. So practically speaking, the way that we've set this up is through this idea of this collaborative adversarial cycle. And so first, what we do is we, as a team, collectively identify our assertions about some given topic. So this is what we believe to be true. Out of that, then we come up with an idea for an experiment, and then we perform that experiment. Out of that experiment, we collectively evaluate reality. So now that we've done this experiment, what are the results and what does the data actually say? And then finally, we come up with this idea of identifying lessons learned. So in this layout, everything is entirely purple. Everything's collective. We have red and blue working on all of this step together. But then we separate intentionally. We have blue and red both go off in their own direction and then create their goals and then complete those goals independent of one another. And then out of that, both teams come back and say, now that we've made these changes, now that we've made these improvements, now that we have new capabilities, what are our new set of assertions? And so this comes into the cyclical process where you repeat. The other way you can tweak a lot of these different touch points. The one that we've had most success with as well is playing with the experiment phase. Sometimes there's an advantage to intentionally splitting out the experiment through red versus blue. When we talk about purple team, we have a little bit of a different perspective on how we use it. I think it's the same end goal, but we leverage purple team to do research that helps us protect our clients tomorrow. We're looking forward, what do we need to do today to prepare for tomorrow? And so our purple team is very externally focused. For many people that are listening, I suspect that they will have their own internal purple team. And so they will be using that to help improve their own security. And so in those cases, especially, I think it's really good to have that experiment phase be split apart where at least during a portion of it, red and blue don't know what each other are doing. So from that, I think there's a couple of key points that might sound familiar. There's this idea of identifying insertions, performing an experiment, and then evaluating reality. And that sounds very similar to the scientific method. And so as we were looking at this and thinking about this collaborative cycle that we've used both with our external purple team engagements for customers and internally for our research team, we started to structure our quarters around this idea of building on top of the scientific method. I love this quote by Richard Hamming. He wrote Hamming Codes, helped with the invention of the transistors with Bell Labs. But he said, in science, if you know what you're doing, you should not be doing it. In engineering, if you do not know what you're doing, you should not be doing it. And that I love that idea. And we actually set our quarters to follow this structure. So this is our last two research quarters. In fact, if you look at the dates, you can see that we're still in the back end of the FY22 Q4 schedule. But there's a couple of things that I'd like to call out. So first, the way that we structure our schedule itself, we treat as an experiment. We've been doing this for a while now, and we continually are tweaking knobs to figure out the best way to structure our research time. And what we found works for us might not work for your team. So I would encourage you, if you try to build a similar structure, always treat it like an experiment. Always identify the variables that you want to tweak, try it out, see what happens, and learn. But at a high level, we have what we call our fundamental research phase and our applied research phase. Our fundamental phase is really the science phase. This is where we do a lot of our experimentation. We tell our researchers that they have very little loss of expected. Like they can go and they can take risks, they can make mistakes, and if the outcomes are completely pointless or not valuable, it's okay. The whole point of the fundamental research phase is to try things out and to understand new technologies, emerging threats. It really also, we structure it as a very divergent process. Science is not always divergent, but we have set it up so that in our case it is. We run that largely as an individual exercise. There's the option for the team to collaborate, but individuals can go off and do things on their own. This is often where the idea of a new red capability or new blue capability will come about. And so we have this divergent thinking that's really exploratory that then feeds into a selection phase. And that selection phase is really how we justify our work to the company. We really don't get paid to just do work. We get paid to do meaningful work. And so this selection phase gives us a chance to consolidate all of these divergent ideas. And then at the back end of that selection process, we present it to leadership, and then they can align with the rest of the company's objectives and say, out of all the things that you proposed, this is what we think is most meaningful for us this quarter. And then out of that, we come up with these structured applied research phases, which is where we already have a pretty good idea of what we're doing because of our fundamental experimentation. But we then feed that into a project that has very specific outcomes that are time bound and are tied to actionable value to the rest of the company. I think the only other callback is that this is a cyclical process. So you can see that we repeat it from quarter to quarter. Oftentimes what we'll see is one applied research will come up with a new offensive capability or a new defensive capability, which will feed into the following fundamental phase where red tries to counter blue and blue tries to counter red. And so you see how we intentionally have our locking of OODA loops throughout this process. We're both trying to make each other work faster. So this is kind of the philosophy of why we structure our team this way and how we've structured it from a scheduling perspective. Ryan's going to talk about a lot of the infrastructure that has allowed us to move quickly and be successful.
Thanks, Trenton. So today I'm going to talk a little bit about what we call the Purple Labs, which is our home for this kind of experimentation. It's really hard to say whether we pick the technologies that we use that support our workflow, or we had to adapt our workflows to the technologies that we had available. But in any case, our entire research workflow really revolves around GitLab, and our entire tech stack is kind of derived from that fundamental relationship. So we, beyond the obvious use cases for GitLab, for version control for code, and for your CI pipeline to deploy things like infrastructure as code, which we use for our labs, and I'll talk about in a moment. GitLab is also like an 80% solution to a ton of other problems that we have to tackle in our research. So we use it to stay organized using the issue tracking and the Kanban boards for individual projects. But we also use it as a form of a document or knowledge store where we put in things like project proposals, reports and findings from a given experiment, and ultimately as like a knowledge management system where we try to distill our wisdom into something that can last and we can take into the future. So before I go into the details on the technology, I just wanted to touch on one of the potentially inherent contradictions that Trenton kind of illustrated earlier, which is that how can you have a purple team and a lab environment? Because in most cases, when you're talking about a purple team, it's a point in time exercise that involves your real environment, right? But for us, as Trenton mentioned, purple is sort of a steady state for us, not just an exercise. And as a security vendor, we have many different organizations that we protect, and they all have slightly different environments. So we have this pressing need to be able to come up with close approximations of what those different environments are so we can perform our experiments in them. And these environments are supposed to be kind of the home turf for the network defenders. And we realize that it's not always exactly perfectly accurate. And we find that embracing that difference and being very hyper aware of it is actually a really positive thing, because when we can actually use the lab as a component in the experiment itself, it can justify why a given change in configuration that we can demonstrate will stop the attacker, why that may be worth doing in the real environment or vice versa. Right? But because we have so many customers with so many different environments, one of the fundamental asymmetries that we struggle with is that the skills required to attack these environments and the skills required to create them are radically different. So we try to come up with a way to consolidate our infrastructure and automation so that way, or rather, we did not want to consolidate it in the hands of a few individuals, which become a bottleneck. Rather, we have the shared responsibility across our whole team to take care of and create and curate these environments. So we came up with a couple of abstractions to help make this a little bit easier for everyone to use. So unsurprisingly, we're in the cloud. We happen to be doing this in Azure. We've asked our really passionate infrastructure SMEs to focus on a lot of the lower level components and plumbing of the lab. So anything that was shared among multiple environments, generally, we would have that kind of team really focus on. And most of the work they do is embodied as Terraform code, which we deploy via CI. So they're handling anything that involves segregation, management, or any shared service that we expect to be commonly used across all the environments. On the researcher side, there's an expectation that all of us are responsible for building the specific resources that go inside of those lab environments that are available to us. So we're using a combination of ARM and Bicep templates, which we actually think Bicep has been really nice to use so far. And we've come up with some pretty complex deployments that we can do there for a variety of our experiments. One point I would like everyone to be mindful of, though, is that a lot of the infrastructure as code you may find on GitHub that's specific for attack emulation type of stuff. Be very cognizant of the open source licensing on those projects, because it may not be compatible with your organization or your legal team. So I want to drill in on a couple of things that I'm really passionate about in our Purple Labs environment, and that's the shared services layer that every researcher gets to benefit from when they do an experiment inside of our Purple Labs. So we decided to basically create some paved roads in the form of an API that can do and perform common lab functions. So things like deploying an environment, taking a snapshot, collecting evidence, backing up systems, tearing things down. It makes a lot of sense to consolidate all of these in an API layer that's convenient to use. We decided to go with the serverless approach because these are both called relatively infrequently and they're short-lived operations, but we really wanted to explore different ways we could go about implementing them and get the most bang for our buck. We ultimately decided to go down the open API route, which allows us to, as you see on the far left side of the slide, in a YAML definition file, we can explain or declare what our API should do and the type of objects it takes. And then we can leverage code generation tools like Microsoft's AutoRest tool to actually scaffold out and again, generate the code for what would become the Azure function backend that implements all of our different APIs. Next slide. Having all of this functionality in the lab is really great, but even in a lab environment, you don't want to give people, average users, really sensitive permissions like global admin or contributor rights on the subscription. So we wanted to find a way where we could allow low privileged users to perform otherwise high privilege operations like deploying a new lab. It makes a lot of sense then to, instead of assigning the privileges to the user, we assign it to the function in the form of a managed identity. So we could consolidate what was, again, required for our users. And then role-based access control is really then a function of who's allowed to call which functions. And an API gateway is exactly the type of mechanism you would typically use or reach for to solve these type of problems. And once again, with OpenAPI, we were able to take the same definition file we used to create our Azure functions, put that into the API gateway in Azure, and then start assigning specific, basically user role assignments that this user should be able to call this privilege function, but not these other ones. And allowing us to do that meant we could have low privilege users with really nice secure APIs that could do the sensitive things we need them to do. And then last but not least, with the OpenAPI stuff, having the APIs as Azure functions is great. Most people are comfortable making REST calls, but to make it a really paved road, we decided to take the OpenAPI spec and using projects like the OpenAPI code generator actually, again, code generate the client code that would be basically ready at hand to call those APIs and interact with them in a way that the researcher is sort of most comfortable doing. And the more complex functionality instead could be built out of those client components rather than needing to have a giant sprawling set of API backends. Makes it really convenient to use these. So obviously, the type of infrastructure I've been describing, these are really conventional things, right? They're not that crazy. And there are tons of scenarios we might want to do or labs we might want that don't quite fit into this mold. So here's an example of an experiment we did from last summer. It was a multi-cloud compromise scenario where a compromised O365 user account is used to trick a Power Automate bot into inviting the attacker as an external collaborator to the organization's GitHub account. Once they have access to GitHub, they were trying to obtain secrets in the CI pipeline, which they could obtain by committing a code in a branch, and which would have access to read those secrets and exfiltrate it to the attacker. Now, obviously, again, this doesn't fit into the kind of mold that we have with some of the more traditional infrastructure type of things. So whenever we're talking about SaaS, it generally becomes a little bit more complicated. My word of wisdom is that if you are going to have multiple environments like the ones I've been describing, feeding into common SaaS solutions like an XDR tool, it's really important that you find a way to isolate the data that's sent from one lab versus another. I can't tell you how many times I've wondered whose DCO1 got popped. It's really hard to tell if we don't tag them appropriately. The next really core fundamental tool chain, a tool in our stack rather, is Jupyter. I could talk about Jupyter forever and ever. It's really incredibly a powerful tool. But the long and short of it is that we take stuff that machines understand in the form of code. We take stuff that humans understand in the form of some sort of descriptive language. We put those things together in this browser-based, interactive, executable script effectively. And it's really incredible the type of applications this basic, simple technology kind of has. So it's really great for ad hoc work, like doing exploratory data analysis, or otherwise trying to, again, find the bad guy in the data. But also because you can hand one of these notebooks to your colleague and say, here, run this. And if you have the same inputs in the same notebook, you should get the same outputs, which makes it incredibly useful for reproducible tasks as well. So in the context of Purple Lab specifically, we use it in all the same ways that the other disciplines use Jupyter Notebooks too. So it's a way for us to codify how we do lab provisioning, a way of embodying specific attack steps that we can repeat in an automated fashion. So again, look for threats, or to summarize the kind of wisdom of how we found those threats in the form of a process guide or something that's repeatable by maybe a security analyst. And ultimately, like everything else we've talked about, to bring it full circle, we use extensions like Jupytext to take these notebooks and put them into a nice, convenient plain text format that easily are put back into version control in our GitLab for the future. The last core piece of technology I want to talk about is called Obsidian. This is one of our knowledge management sort of solutions that integrates, again, super duper well with GitLab. Basically, all of the things we want to include in our GitLab from a documentation perspective, it's all just marked down. And Obsidian allows us to link together things like tags and core concepts that we want from any of these documents inside our vault to all the other documents which may be produced by other researchers. What you see on screen is actually just a representation of like the MITRE's attack framework. And we can then take any document, put any technique tag in it, and now magically, if any colleague opens up our vault and they're interested in a certain technique, they can immediately see that your work was linked to it and go figure out what you were doing. And then lastly, but not least, this type of research can be really pricey. It's expensive to run a team like this. We also really want to be focused on what our core mission is, which is to defend our customers, right? So like people say knowledge is power, but in my opinion, knowledge is not enough. We have to be able to convince people to change their behaviors in order to really turn that into something useful. So here are just a couple of aspects of ways to evaluate whether our research was successful. So looking at trait improvements, how has our research been integrated into some core piece of technology that other teams are using? Process improvements, which is like, have we taken this research and turned it into something, changing how a service is delivered or changing the checklist for a security analyst? It's also really hard to measure organizational impact even inside one company. It gets even harder when we're trying to think about how has this research impacted the broader community. So we try to find different ways to measure that. For marketing folks, that can be like, how many clicks are we driving with our blog posts? How many conference talks or papers are we publishing? Or better yet, how many CVEs did we release that may have resulted in some radical change to the threat landscape? And then lastly, but not least, again, we're here to try to find actual malicious adversaries. So anytime we can directly connect the output from our research to a specific threat that was detected in a specific customer environment, those are super convincing stories that justify why this type of research is important and that ultimately we were successful with what we were trying to do. So that's kind of a whirlwind tour of what we've been doing in our Purple Labs and our research team. But thank you so much for listening, and yeah, stay safe out there.
Thanks.